Hi, we're going to talk about displacement and distance. We have a little difference between the two. Displacement, you should know it is a scalar. We learned in the last video that scalar just has magnitude. It doesn't have direction. Okay, so this has magnitude, so how much of something, and it also means how far removed from a specific point. Okay, so what I mean by that is if we have something in, let's say, Iowa, United States, Iowa, and let's just use states. There's just one of the states in the United States. And let's say an individual lived in Iowa, moved to Nebraska, then moved back to Iowa. The displacement of that person is still in Iowa. Okay. I'll get to an example in a second here. Let's talk about actually let's do the example right now. Let's look at this. Let's have a person. All right. This person is standing on a giant multiple meter stick. Okay. And we'll have them start at 1 meter. So the ticker is at 1 meter. Okay, we'll do M for short moving forward. We have 1 meter here. This person, let's call this 2 meters, 3 meters, 4 meters. Let's just go to 4. This person goes ahead and goes to 3 meters. Okay, it's the same person. All right, they're at 3 meters. We'll call this point A. We'll call this point B. So this person has traveled a total displacement of 2 meters. So we can say that the displacement (2 meters). Now, what if I can pose a question here? What if we traveled, or this person traveled from A to B back to A? What is the displacement? So so this is question 1. Question 2 will be A to B back to A. What's the displacement? Well, the displacement is 0. It's nothing. The person didn't achieve any removal from the specified location. And the specified location, or the starting location, was A. Well, they ended back up at A. So the displacement is 0. All right. Let's talk about distance then, because I could knock displacement around forever with the same concept. Okay, this is a vector, which means that it has magnitude, but it also has direction. Okay, so I should say, well, I mean, yeah, direction is going to come into place. Let's be more specific. I'm going to say, yeah, let's say that it has direction, because you're going to want to account for the direction that this person goes. On top of that, it's the overall land covered, or overall, I'm trying to think of a good way to say this, the overall change the object makes. So let's talk about that. We'll use the same thing, but down. Let's use the same person right up here. Okay, so we have this person. They travel. So remember, this was displacement here. Let's do a third question. What if we traveled A to B to A with distance? Okay, so with distance, we have A to B. And if we had the reason why I want to say there's direction here. Ooh, that looks like a north. Let's say this is south, east, north, west. Well, this person travels east, goes to B, and then travels back west. Okay? And there's going to be a reason why that's important, and we'll get to those in some more advanced questions. Okay, so anyway, A to B, back to A. Well, A to B is 2 meters. So we have a whole 2 meters here. Then B back to A, well, that's 2 meters again, because it took 2 meters to get there. So we're just going to do 2 plus 2. So the total distance is 4 meters. Okay. The displacement was 0 because the individual, as we talked about, didn't really remove themselves from that position. Imagine you walk into a room. Let's say it's a parent and their child is playing video games. And the parent, it just so happens every time the parent comes into the room, the child is playing video games and the parent goes, "Get out of your room and go outside." The child states, "I was outside." The parent doesn't believe them because what they see is a displacement of the individual. They still see the individual at point A, so they just get frustrated. Now you think you're arguing with them, but really what you're trying to do is describe distance. And you're trying to tell them, "I was outside at a specific time, okay? And then I came back into the room at another specified time, point A to point B, back to point A." Again, all they saw was displacement. You were still in your room from when they checked and the last time they checked, but in between that, you did go outside. Okay, let's say you obliged to their discipline and you went outside. You can think of a lot of different questions like this. We'll go over a few examples here. All right, in big examples. Okay, let's have Charles travels 10 meters outside of his house, then arrives back to his house. So, a simple question. Charles travels 10 meters outside of his house, then arrives back to his house. Displacement? Think about that. Travels 10 meters outside of his house, then arrives back to his house. Displacement equals 0 meters. Okay? Again, arrived back to his house. It was written down. There's no numeration for that in the sentence or in the question. But what about distance? 10 meters outside of his house. Well, we don't know exactly. So let's fortify the question, because 10 meters outside of his house, 10 meters outside of his house could mean a plethora of things, right? Could mean a whole lot of things. He could travel down a full 10 meters. Shoot, I keep erasing this. Down a full 10 meters. Well, then he'd have to come back 10 meters. So that distance would be 20. Maybe. Or maybe he traveled let's erase this. Maybe he traveled 10 meters outside of his house in a circle, leading him right back to his door. And so the distance would be 10 meters then. It doesn't really describe where. And that's why I'm talking about we need direction with this. We need to hear direction for us to really answer a distance question. A poorly written question would be this if we weren't conceptually trying to explain why it's such a bad question, because you need direction or else nobody's going to understand what distance. If I said travel 10 meters to my house and you've never met me before, you would say, well, which way do I go? I don't know. So we can easily insert travels 10 meters east, just a straight up east. If we had our compass here, north, east, south, west. So east 10 meters, and then arrives back to his house. Well, then to arrive back at the house, you're going to have to come back 10 meters. It doesn't describe that essentially in the question, but I think we get a general drift as to what's occurring here. So in this case of east, the distance would be not 1, but 20 meters. So I could do 1,000 questions like this. We'll do another video with more advanced vectors and analysis of direction. Thanks for watching, and I hope you have a great day. Oops.